Hello and welcome to the second video in this series. During this video we will be talking about ammonia. We will start with a little familiarization. Ammonia's chemical formula is NH3. It has 3 hydrogen atoms, which are all bonded to one nitrogen atom. It is commonly found in cleaning fluids and is used to produce nitric acid. This nitric acid is then used to produce explosives and fertilizer. The main source of ammonia is the Harbour process. In order to carry out the Harbour process, firstly we need hydrogen. This can be obtained through either cracking of oil fractions or reacting methane with steam. Secondly, we need nitrogen. Alongside oxygen, nitrogen is abundant in air. We can obtain nitrogen from this source by burning it with hydrogen in order to remove the oxygen. Having acquired these reactants, we can now produce ammonia through a reversible reaction. The conditions for this reaction are 450 degrees Celsius, 200 atmospheres of pressure, and in the presence of an ion catalyst. This diagram illustrates the Harbour process. In the first stage, hydrogen and nitrogen are pumped into a compressor. Inside the compressor, they are pressurized to 200 atmospheres. They then move into a chamber containing the ion catalyst, where they are heated to 450 degrees Celsius. In this chamber, the reaction occurs, and a mixture of ammonia, hydrogen, and nitrogen exit and enter a cooling tank. In this tank, NH3 is condensed and collected as a liquid. The hydrogen and nitrogen are then recycled back into the chamber containing the ion catalyst to reduce any waste. The conditions under which the Harbour process is carried out are chosen because they are considered ideal for economic production of ammonia. You need to know that reaction yields are affected by the temperature and the pressure. When pressure increases, this favours the side with fewer gas moles. In the case for the Harbour process, that is the side containing ammonia. However, increasing pressure too high can cause a risk of explosion and require very expensive equipment to reduce that risk. When increasing temperature, this can favour the endothermic direction, the side with nitrogen and hydrogen, thus reducing the yield of ammonia. A low temperature would favour ammonia yield, however, this would reduce the rate of reaction. This can be counteracted with the addition of a catalyst, which will increase the rate of the forward and reverse reactions. The stated conditions for the Harbour process are called compromise conditions, as they offer a good compromise between the rate, yield, and cost of production. You also need to know the test for ammonia. At room temperature, ammonia is in a gaseous state. So to test for it, we can use a damp piece of red litmus paper. If ammonia is present, this paper will turn blue. The test for ammonium ions is very similar. However, there is an additional step. A compound containing ammonium ions can be added to a source of hydroxide ions and heated. A good example would be sodium hydroxide. This reaction will give off ammonia gas and water. At this stage, we can reuse the litmus test to detect ammonia gas. Thanks again for watching. I'll see you in the sulfuric acid video.